The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
You always have things to do, though.
Yeah, it's the name of the game.
Yeah, but you're always fixing the same Jeep.
Yeah, that's what you do. You break it, and then you fix it again, and then you break it, and then fix it again.
Did you finally get the thing running from the pressure transducer or whatever you were trying to figure out?
Yeah, after 7 different high pressure switches, I finally found one that fit.
And then when it's a fit, did it start working then?
I don't know yet. It's low on gas again.
Ain't got no gas in it. Unbelievable.
I'm out of 134A.
You're such a bitch. You're like, I'm a rough and tumbling, rock tumbling guy. I was like, I need refrigerant. I need a low charge. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. Yeah, I was talking to our buddies today over at Pro. Damon says hello.
Oh, hi, Damon.
So what do you know? What do you say? What are you doing this week?
Did you
see Greggy this week?
Yeah, little bitch.
Why? What happened?
He was supposed to go to lunch with me, and he ran away like a little child. Nor did he bring us any food where we were actually working. He was just moseying around.
Didn't even try to give you a hug?
Yeah, he looked like a foot shorter.
What do you mean he looked a foot shorter?
I don't know. I think he shrunk.
Do you shrink from sitting in the chair all day in the morning?
He may be shorter than James now.
Come on, there's no way.
I'm telling you,
no.
He shrunk.
There's no freaking way. James is like, I'm not gonna.
Don't be
he's
mean.
Like 5'5".
No, he's not.
I'll give James 5'5".
5'10".
The picture of him and I together looks like I'm taking my kid to school.
5'10".
He's not. There's no freaking way.
You're just 6'4".
No, I'm not.
No, I don't know. Greg just was moseying around. I go, must be nice. You get to eat free lunch and not bring us any.
So besides breaking Greg's balls, what else did you get to do?
We were in a shop, pre-programmed some Walmart controllers, and other than that, it's been prepping for some jobs and finishing up a bunch of VFDs.
Greg come up to help you with the VFDs.
No, and we're doing these Danfoss drives at Albertsons, and I swear to God, every single one of them is different. You go to one store, they all have this bypass board in it. Okay, figure out how to wire them.
That's the one with the green board up top.
Yes. Okay, there's 2 different versions of that green board. Go to the next store. This is a different version that is completely different. That has no bypass customer support input, so it's only got a fireman's override.
The switchy.
No, so it's an input. So then I look at it, then I go to the next store. It's completely different again. These all came out at the same time. Husband ordered all these. Then this next store was just standard 120 volt inputs to switch bypass. I go, thank God. But it's made it a nightmare because the electricians are trying to pull all these, and they pulled the 120 volt one and 18 4s. It's shit. Now we got to switch this out to 14 gauge wires, and this has been a bit of a nightmare. But it's I'm trying to show the apprentice how to program these so he could do them. And it's okay, you do this one. Shit, this is different. Okay, all right, now let's try this one. Do this one. All right, this one's completely different.
Is your cat getting fatter?
Maybe he doesn't move out of the room very much because of the dog.
Because like it looks like double the amount of cat that it did last week. I think
Maybe
it looks like a pile of yeah.
He's if the diabetes don't get him,
It's the cartman of cats.
his belly dangles the floor.
No exercise running from going in the room.
No, he just
I
lays
saw you
there.
got the cat thing out of there.
Yeah, he just lays there while the puppy attacks him. Doesn't even try to fight back. Too much energy.
Does that mean the cat needs 2 seats at the airport?
Oh yeah.
That's so fucked. What am I doing? Training. I was like doing curriculum. I got a class that I could teach out in Fort Worth this week, Wednesday and Thursday. It's an industrial type job, parallel compression. And yeah, it's all right. So I'm going to share I'm going to share this. Have you ever seen, this is the first time I've ever seen this ever. And if you've seen it, I'm going to cry.
Because I thought 5 minutes in and you went right to fucking potato on left field.
I know what happened. Because I've had this on my mind for a while, and I wanted to talk to you about it today, but you were too busy berating the kid. Let's see. What would it be? P and ID.
What are you doing?
Trying to find something. Stop it. I was trying to get something off there so it's not on there when I go to bring this up because I don't want the name up there. All right. How come it's not going? Oh, that's why, because I'm not sure in that way. Look at that. So it's for a dock unit, and it has a reheat coil in it.
Yeah.
Have you ever seen that ever?
Yes.
What?
Yeah.
That's really amazing.
Docks have a ton of humidity.
No, I know that, but like I physically myself, I've never seen that, which I thought was crazy. So there's a whole nether circuit that basically runs reheat to raise the temperature. Fine, you're not interested, so I don't care. So what are we talking about today? Since you're not interested in what I thought was really super cool,
we are going to talk about Microthermal 700 circuit controllers. Go through the basic setup and kind of cruise through this, and I'm going to get really frustrated while you're looking around to click things. And
it gives me a chance to absorb.
Okay.
And
no.
And, what do you mean no? Just say
no.
It gives me a chance to absorb and what I'm looking at. And then you're not clicking like a main man. I could probably give you access, but then it wouldn't be as fun, like irritating you while this is going on.
No, I would fuck with you all day long.
Oh, you do anyway. Anyway. Okay, so you just want to create it from scratch?
Create it from scratch. Let's go.
So you're going to go to node. You're going to go to node.
No ad.
What?
The no ad.
And then we're going to pull the node anywhere on here. And did I do the wrong one? No, I was supposed to do plugin.
No, you already dropped the plugin. So you dropped the plugin already. So the plugin's right there on the side underneath the notes.
Oh, that plugin.
Yep. So this is your circuit controller plugin. I can click it.
I'm clicking it. I was bringing it over so it's easier to see. I'm old. My eyesight's actually starting to really go bad. If I'm starting to have to hold medicine bottles, like keep going like this. What in the other? There we go.
Yep. Welcome to Microthermal. Okay, name it. First thing you're gonna do is name the plugin. So name it Brett's Circuits. Fuck you. Okay, so now you're gonna go to. You have to create one node right away. So you got the create node, create circuit node. That it's going to be on the backbone, or if it's on a router, it's there. You're gonna hit that.
Hold on, I just want to explain this real quick. So you explained this to me the other week in case someone missed it. So backbone would be if it's on the straight LAN card that's actually connected to the data log.
Yep, and then the routers would be anything that is tied between the LAN card and a router. So if the LAN card would go to a router, starts a new segment in Microthermal of boards. Gotcha. So you could have multiple segments. So
see, this is the reason why I do this. Not just to irritate you. It's just a bonus. All right, we're going to make it CO2?
No, make it 448 because it's way cooler.
Are you serious?
Yes.
God damn it. Okay.
Make it a CO2 and 448.
Anyway, what do you want?
I don't care. Pick whatever.
Since we're doing CO2, I'm going to keep it CO2. Put it on the first group one. We'll put it on the low temp or medium temp. Does it matter?
We'll do low temp first. I always do low temp first.
All right. Direct expansion.
Yeah.
Okay.
And then you're going to tell it what you got. Whether you have a 700 series suction group, if you have a TC rack suction group, hopefully it's 700. Yeah. What it is, low temp, medium temp, ice cream.
All right, so why would you have that? Why would you have low temp and ice cream?
I have no idea. Because you could change the suction saturation to whatever you want.
Whatever. Anyway, suction saturated temperature set point before floating.
-20, I guess.
Okay.
Yeah, you're better off just clicking over it because it's going to go in decimal points. Yeah. Okay, defrost type. So we'll go electric.
We didn't do a hot gas suction header, if I'm not mistaken.
Okay, suction group. It's going to pick one.
ARP low.
Yep. See, it linked all that. Frosted by medium temp. So it's saying that if the defrost diff valve was tied to anything, it'd be tied to that one.
Okay.
Okay, so hit OK.
Or what's equipment and features?
Oh, yeah, go to that. Sorry. So this is where you choose your equipment.
I had a question for you. So I was looking at a case controller the other day, and there was not enough outputs. There wasn't another bipolar output. So if you had a case controller and you had in Microthermal, if you had to hook up an EPR, would you have to do it to another 700 series board, and you just link it up that way?
Depends. You would use the circuit controller node. You should use the circuit controller node.
It didn't have another output though.
So I'll explain it here in a second.
Okay.
So this is where you're going to click for what you have. So refrigeration, if you have a main liquid line solenoid, master liquid line solenoid, if it's controlled from air temperature, you can click that. If it cycles on and off. If you have dual temp EPR.
You want me to leave that on there?
No, you can click them all. I don't give a shit.
Okay.
So pilot suction valve, if you have pan heating, if you have fans, if you're doing circuit superheating monitoring, if you're doing dock heating, dual temp and circuit clean. So this populates other menus inside when we go to program. Is click the dual temp EPR one.
Wait, that one?
No, the one you missed. Yeah. Yep. So hit OK. Okay. Then go to preferences.
I have a question about environment though.
Dude, I take all the environment corrections out usually.
Okay, sorry. So
go to preferences.
Preferences or processes?
Right next to environment.
That one, okay.
God, this screen is so shitty. Change it from KW to BTUs an hour. Yeah.
Okay.
BTUs an hour.
Okay.
Oh my God, it's so much easier to see now.
Maybe
no, it's just when I zoom in, it gets blurry. Go to global. Nope, same bar as environment.
Global. Gotcha.
Okay. I can't fucking see.
It says day and night, start day, start night. 6 a.m. 2300.
So you set these up, and it's the same as everyone else.
Is this because it would control the lights basically off this, or is that a separate schedule?
It's just for your day and night for the environment. So you don't have to click anything with this. Click out.
Okay.
This is base settings. You can go to alarms if you want.
Okay. You call home. Use alarm.
Missing data alarm. So I disable these until I'm doing a retrofit. I disable all the missing data alarms until I'm done programming. And
Oh yeah, 'cause every time you pull a sensor, it's gonna throw an alarm, right?
Yep.
Okay.
Then even if you bypass it on the screen, it's just gonna throw it in another board. So hit OK. Yep. Go out of there. Okay. Now you're gonna want to hit apply.
Does it do anything with emergency groups?
You can if you want. If you are using the emergency groups,
That would be connected to the suction, right?
Yeah. So you could use emergency group 1, use emergency group 2, other nodes.
Oh, and then I'd have to hook it up to the
Yep. So that would be your emergency group.
Okay.
You can link it a different way too, but this way is easier.
Gotcha. Okay.
Yep. So
Anyway.
okay. So hit apply. I just want to show you guys how to start dropping these.
Now I know why you get frustrated.
I really wish you didn't have boards like service pinned on this thing.
I don't have any boards connected to it.
Oh wow.
The boards that are up there don't even have power on it. I'm starting from the bottom up.
Don't put power on them.
Anyway,
Hey,
all right.
Go to process.
Can't yet.
Top now.
Can't yet.
Don't click when it's doing this because it gets.
I didn't click. I'm just letting it do its thing.
I can only imagine me with my impatience. How
That's why I was wondering, like, why this is why you get so pissy when you're doing the Bosco work, because like you're like, this is taking forever.
Yeah.
Yeah.
It's usually not as bad when there's not board service pinned. It's usually pretty quick.
Boards
I don't know.
pinned.
You got a really old version of Alliance, though.
Man.
You'd ask somebody for an upgrade.
I'm going to. No, I've only been staying up until 1 o'clock in the morning every night.
We should stop doing that.
Oh, I got shit I got to do.
Get a helper.
I'm working on it. If I could go through all the people that wanted to be. Go ahead. Process. Yeah.
Yep. Go to process.
Okay.
Okay. Now, see, you got one circuit on there. Now, say we want to add more. So before we do that, so go down. You see the little pen? No. Look down there. See the pencil? Click plus. Okay. That's going to add your circuits. Jesus Christ, you're a child.
I know.
Okay, so you're going to click on the first circuit. You got the 3 lines. I don't know why everybody calls it hamburger. It drives me insane.
Looks like a hamburger.
Some fucking shitty Texas hamburgers.
Hamburger.
Anyway. Pig. All right, so now go show control at the bottom before you do anything. All the way to the bottom, white box, hit that. Boom. Get everything now. Okay, first things first, you're going to name it. Whatever you're going to name it. Just name it A1. My OCD wants to kill you right now. A1 freezer.
That's why I did it. Dude, you're gonna say some shit about that.
Holy shit. Under thermal load, you're gonna click that because this helps you with your defrost schedule, so you can make it whatever you want it, whatever it is. Oh my god. What suction group it is? So you want to change this to suction group 1. Click the little white box.
Okay.
Or is this suction group 2?
No, we already did. We already linked it up before.
Oh.
We already linked it up. Remember, we linked it up in the other thing, in the other place.
So then you're going to give it to emergency group. Emergency group 1. Okay, now you're going to tell it what kind of temperature control it has. Now listen, if you're just running off a standard EPR, you're not cycling on temperature, you're going to click none. Okay? Mm-hmm. If you're using case controllers, that's going to be clicked. So you have this equipped with case controllers. So it's going to be controlled that way. If you have an EPR, electronic EPR, you're going to click that. So click the electronic EPR.
So if I know electronic, then that's the only, or a manual EPR, I'm still going to hit EPR?
No, if you have a manual EPR, you're going to hit none.
Okay. So this is just strictly for an electronic EPR.
Yes.
Done.
Okay. Now, the other thing is, so you have this set up for a case controller. You see how it's grayed out there? If it didn't have case controllers, you would be able to cycle it on temperature.
Gotcha.
Okay, so now loads, whether it's cases or walk-ins, if you don't choose walk-ins, you're not going to get the fan cycling set up in it and the other solenoids. So I always just choose walk-ins for now. You get more menus with walk-ins than you do with cases. So
Does that mean is that also what gives it the door switch input as well? Okay.
Yep. Okay.
So all right. So stop. You could also use that for an input for a leak detector. Then technically, like any kind of other shutdown.
They have their own. They have their own leak detector when you choose walk-in. So it populates a whole nother menu for you. Like I said, you don't gain anything different. Like it doesn't show anything different on the screen. Okay. So delay after a power outage. So this is where you would set up your delays for your EPRs.
Okay.
So this is where you'd set up all that. Now, EPR open progressively for 10 minutes. I don't really mess with this too much because there's another screen here under the EPR screen. Okay, so if you use an electronic EPR, this is where you're going to tell it what it is, whether it's analog output, stepper. It's going to give you Sporlan, Danfoss. Everything's going to be preloaded in here.
Gotcha. All right, so let's do
CDS 16.
No, I was going to do your favorite one. The switchblade of EPRs. CDS 9.
Okay. So then you're going to give it the module number and position. So you could do this in two ways. You could do it in the way we assigned it earlier in the last one, where you click on the pictures of the boards. I think that's way easier. Or you could do it in here and give it a position. But we're not going to be able to give it a position right now because Brett didn't drop any boards. Which we'll do that in a second.
Okay.
Okay. Ramp up setup all the way to the right. Now, this is where I spend a little bit of time. So hit ramp up setup. You're going to play with this a little bit. Now, this is your stages of opening, and this is the time post defrost or after a power outage. So bottom is power outage. Top is going to be your post defrost. So this is what it opens to in stages. So you can see on there in the beginning, it opens to, what is it, 3.5? I can't see, 3.75.
Yeah, 3.75 after 0 minutes. And then after 30 seconds, if we're talking about after defrost, then it's 7.5% after 30 seconds. And then it's after 1 minute, 16.25. And then after a minute 30, then it's 25%. Until the end of 2 minutes, and then it goes back into normal refrigeration.
There is some of these I have at 20 minutes.
You're talking about for like a pump out. You're basically using like a pump out so it doesn't flood out the rack.
Because you have a massive, or overheat the rack, because after a really hot gas defrost, you may have 120 degree gas in there, 130 degree gas in there after a drip that's coming back. And some of these 448 racks do not like it. And then some versions of Alliance where they had a bug, which most of them should be fixed by now, but the timing circuit for the EPR drip down was starting when the coil will go to the drip. So a lot of these were set to 10 minutes, and then it would have an 8-minute drip or 5-minute drip. Then it would be like 50% open by the time it was rolling around.
Damn, Daniel. Gotcha.
So that's one thing so if you see ones with 20-minute like long pull downs, then that's what's happening.
So let me ask you a question then. So I could actually adjust these values.
Yep.
I can make this a higher number. Technically, I can make this a higher number. And then I could technically put this down all the way down to 0, and then step it up surely, right?
Yeah, I'll go like 1.5% and just enough where it starts bleeding the gas pressure out.
Gotcha. Okay. I just
like I said, this is like a play around thing because like bigger coils, you're going to take longer. Small coils, like cases, you're good with a 5-minute, 10-minute ramp up.
Gotcha. Okay. Cool.
So you can click out of there.
Well, real quick, and then like you said before, power outage, group emergency, or walk-in emergency. Basically, 0 was a 3.75. After 0 minutes, it'd be a 3.75. After 2.5 minutes, it just basically extends it. After a defrost, you want to get back quickly, but after just for a slow ramp up of the rack, basically that's why we have these down here. Okay.
Today's episode is sponsored by the RefRuShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. but replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Next.
Okay, so then you got the way the valve is positioned.
Yeah, I don't really understand that radial and let's see if it changes. Oh, what would a regular EPR be like a CDS9? That doesn't make any sense.
It would just change it, whether it's axial or radial, which way the flow is going through the valve. Look, see?
No, I understand that, but I'm saying with a regular EPR, it only can go one way. Oh, I guess again going against the. Oh, okay. So basically, it would have to be axial for a CDS9 because it's going up against the part where it's closing. I wonder if it does something with the what it's pushing against. Because if it's one way, then basically it has to. Oh, no, it wouldn't make any sense either. It's pushing against. I don't know. I have to ask someone. I don't know. Anyway, go ahead. Continue.
Okay, so then you got your maximum open or minimum open. So just like most control systems, where you can set a max open on the EPR if you want to, like 50%, and minimum. I don't know why you'd want to change really the minimum open. Can't really think of many situations where you want that.
No, because you still want it to close off during defrost and that, right?
Yes. So
okay. Step correction, move criteria. Okay, piping restrictions has saturated temp. Oh, so it's, I don't know what that means. Like just the estimate of what the pipe loss is?
Yeah. So I usually bring that down a little bit because it's usually never that high anymore. So you do is a pressure drop, temperature if you want.
Yeah, I got you.
Okay, and then you got your step correction and move criteria. So I have had to mess with the move criteria, the 1 minute move criteria. I've had to change that down to 30 seconds on some stuff.
I don't know what move criteria is. Move criterion is used to avoid unnecessary valve movements, represents the time of discrepancy 1% will be tolerated between the target position and the actual position. When the default value 1, example, if the valve sits at 50%, opens and needs to go to 51, it will wait 30 seconds before moving. That's because the move from 50 to 51 represents a 2% relative change in open percentage. When the background noise changes the calculated percentage, opened up and down slightly, the valve may remain still for a long period of time to avoid necessary wear. So it basically slows down how fast it's going to react so it doesn't overdrive the valve ridiculously much.
Correct. And like some stuff, you may have to go to 30 seconds. Dude, if you have small cases, a minute is not good. So
a minute is not good.
So they have a minute factor in there right now. So if you have a small case that's like super efficient and the rack's floating around, it's going to be all over the place.
So the more sloppy your suction would be, the higher your number would be better.
Yes. No, lower. You want it to move faster.
Oh, okay.
Okay. So this is our EPR screen. If you don't have an EPR and you just click none, this whole screen is irrelevant to you. So if you go to control relays.
Circuit relays?
Yeah, I can't see.
Maybe you need glasses.
No, it's just blurry. Because my internet connection is shit right now.
Tell the kids to stop playing Minecraft.
Yeah, master relay is going to be your suction relay, okay? Or generally your EPR relay, if you're using suction stops, or if you're using a liquid relay, that's going to be or a liquid line solenoid, that's going to be generally your master. So is that going
to be local or remote then?
It could be either or. So remote would be like you had another circuit node in there. So you had another like remote circuit node, like I have one in another panel. I'd use remote.
Local would be the case controller itself, then, right?
No, local would be in the board train itself.
That's what I mean. Like the
There's nothing to do with the case controllers.
Oh, okay.
So this would be in this itself. You could have, for example, I had a store where the liquid line solenoids were remote, and everything else was local. So they had liquid line solenoids at coils.
So I could have my defrost panel all the way the hell back at the rack, and then basically I could pick another node remotely for that.
Yes.
And the same thing with the suction. No, suction stop is typically at the rack, so we could have that remote as well. We could have the fan.
You would have the suction stop as local if it was at the rack.
Oh, okay. You're saying that this is at the rack.
Yeah,
Okay.
defrost would be local more likely because it's at the rack.
Gotcha.
So pan heating I've only used for the heaters in there for defrost, but like most of the time it ends up getting wired to defrost anyway. Fans end up remote a lot. So if I'm using like EPRs, I generally like normal like A8s, I will assign them to the master. I won't assign them to the suction stop. I'll assign them to the master because it's looking for something to be assigned to the master and it sits there yellow. So it's better off is to not have it yellow and look like it's missing something. So I will assign it to the master. The master and the suction stop shut off at the same time during defrost. And master will cycle in temp if you need to. Okay, so you got all these. Now, if you look at there, go back up. Remote. No, click. Yeah, you have the really old version of Alliance. Okay, the remote, they fixed it now. So you could have a satellite node in there. This is an older version where you can only have like bit 0 through 16. That is a software input. Or is it 15? So you have these bits and you can assign it to remote relays. So when it calls for this to be on, it's like a global relay. Okay, it's going to send it out globally. Now,
almost like how the E3 has X amount of global points that you can send out and receive. Okay.
Yes. Now, they fixed this in the newer versions of Alliance when they did the last couple updates, and now you could have a remote circuit node with all these inputs on there, outputs on there. You used to only be able to have certain things, but now you can have fans, everything on there. So newer version, way better. Brett's version, shit.
Nothing is. I'm just gonna stop recording. It's fine. Anyway, so we discussed that my version sucks. So let's go to inputs now, right?
Yep, inputs. Okay, so now you have in here circuit pressure. So if you have local circuit pressure, which we never use, it's pretty much always going to be remote if you're pulling it from a case controller. So if you click on remote, okay, so you can obtain for case controllers, and now you would just choose a node. If you had case controllers programmed, it would just choose it from there. Okay, so you would pull in whatever it is, and that's going to be your suction pressure. If you had an input from, I don't know, if you had like a suction transistor on there, it may be local. Okay, so temperature. Okay, so you got a couple options here. So generally, if you have case controllers, it's going to create automatic bindings from the case controller. When you assign the case controllers to what circuit it is inside the case controller setup, it's going to bind it all for you. Okay, you just got to come in here and click that. Now, if you have sensor nodes, you're going to hit circuit temp to none. So unclick the case controller one. So go to temperature, unclick the case controller. Yep, unclick. You were just on it. Up right there. Unclick. Okay, air temp. Okay. If you were using like standard DX refrigerant and you didn't have case controllers, this is where you're going to assign the air temps to the circuits. So if you click on the air temp, where it says air temperature and then it says select to the right, down, right there. Okay, this is going to bring up all your sensor node variables you have or any variables you want to assign from case temp. Generally, when you're dropping everything on the screen, it's going to be dropped as sensors. So you're going to have 75 case temp sensors in here. Okay, you're going to be able to assign it like A1, A1B, A1C, A1D. You can click all of them, drag them, and then push the green arrow, and it'll assign them all to the circuit.
Gotcha. Okay.
So you could just do that right now if you want to, with whatever that is. Click that, hit OK. Now it assigned it to the circuit. So now go to the air temperature where it's yellow. Okay. Yellow.
It's the circuit temperature.
Yeah, circuit temperature. I'm sorry. I can't see. None. Change it to none.
Is none? Oh, this none.
Yeah.
Okay.
So you got rid of the yellow. Now switch. So switch at the top.
You're such bad at directions. Okay. What is switch? Oh, switch is emergency defrost.
Yeah. So you got that. So you can get rid of that if you're not using it. Just click it to none.
None. Okay.
Okay.
Perfect.
So they got rid of that. So now we can go to pressure regulation.
Okay.
Okay. Now this is where you set up your floating pressure if you're using an EPR on CO2. Like if you're using it on CO2 per se, like you could set up your floating SST. So it's going to give you a set point of whatever you're trying to maintain. If you're trying to maintain evaporator temp or if you're trying to maintain saturation.
Okay, so it is giving a circuit saturated temperature of minus 16.
Yep. So look over to the left-hand side. You see where it says control source? So we got air temp or we got circuit saturation.
You got local pressure, remote saturation temperature.
Yep. That's going to be your SST. If you wanted to control off discharge air temp, then, or whatever air temp you assigned, you're going to click air temp.
Does it give you like a TD? Oh, yes, it does. So you could, okay, all right, cool. So if you knew what the TD was, that basically will close. Oh, okay, all right, so let me make sure I explain this. So if let's just say this is trying to maintain 10 degrees or negative 10, because remember we had the, there we go. So we're trying to maintain negative 10. It'd probably be easier if I highlighted it and just go negative 10. And then
it's so much easier just to highlight it.
And then I just do a 10 degree 10 degree TD, BAMO, and then it'll try to maintain it tries to maintain a negative 10 with a 10 degree TD, so it's going to float around. Okay, all right, that makes sense. That's nice. I was talking to someone about microthermal, like a lot of the algorithms and stuff were based off of actual fluid physics, fluid dynamics, from my understanding.
Yeah, it works great. It's just a lot of adjustments. Okay, so self-learning, turn that shit way down in the beginning because it's too long.
Where is self-learning?
Right,
this right here. How many minutes?
Does it say 40 minutes or 40 hours?
48 hours.
Yeah, no, to make it 24 hours. Okay, you got your PID on here. I generally don't mess with this too much unless I have to.
Okay.
I've had a lot of dual temp cases we have. I have to end up turning up making it less stable and tighter control. So at least they get the bars on there. Generally, the PID is decent on this if you have a correctly sized valve. Jesus, stop it. Stop it.
All right, so we done with this?
Yeah.
Okay. All right, so we're all done with that. So let's
go to defrost.
Oh, defrost now.
Yep, going down.
Okay.
Okay, so this is where you're going to set up now. Defrost type, whether it's electric, hot gas, off time, you're going to click it from there. If you click those other options, they would all show up in there.
Yeah, we gave it electrical from the beginning.
Yep. So you got your pump down, your EPR is in pump down. So you have your active 0%. Defrost. Yep. Well, no, it depends what you want. If you want to pump it out, if you close the local line solenoid and you want to pump it out.
Oh, gotcha.
Because that would be where you would use master and suction stop.
Yeah, because it'd have to have a liquid line solenoid or whatever. Yeah, all right, cool.
It would have the liquid line solenoid to pump out. Generally, we don't want that. We want full refrigerant, defrost faster. Okay. Now you got your drip percentage and your after defrost percentage. Generally, we always want those at 0. I don't know why you'd want the refrigeration on during drip. But down below, you get your fan during defrost. Okay. If it's a case and you're controlling the fans, obviously you want it off. So you can have stop or keep running. If it's medium temp and it's just off time, you want to keep it running.
Or just for the same matter that you might have something, you have this fancy EMS system. And they're like, yeah, we're going to have the mechanical fan control in there. That'd be the only other reason why you'd not do that.
Yeah, if you had mechanical fan control. Okay, if you look to your right, you have the defrost timing. So you got your pump down time. You got your minimum defrost or max defrost because I can't see.
Max
your
defrost.
Drip. Yep. Max defrost, your drip.
All right, and then it says ramp after drip, which it says 14 minutes. And then is that a percent? It looks like a money sign. Oh, it's seconds.
So that's tied to that ramp after drip in the original thing we did from the original screen. So that changes that. Now, if you click on circuit fans.
Oh, that one right there.
Yeah, you didn't click defrost termination, so for some reason on there it didn't. give you a defrost termination from the beginning.
That's weird. How would I go back and fix that?
You got to go hit OK. Go to system. Okay, go to suction group 2. Down below. Up. Down. Right there. Okay, go to features. It's weird.
Yeah, it didn't give it to us. It's really weird. All right. Figure it out later. It's fine. All right, so go back here, go to processes, go back over here to configuration.
Yep. You go to inputs. Temperature. Yeah, it didn't do it. It's weird. Or it's because it's tied to a case controller.
Maybe, so it already knows.
Yep. So go to defrost and then go to circuit fans.
That one.
Yep. So this is where you do your stop fans and your start fans. Like where we were talking about during that ramp, where that ramping was during drip, it was starting to. I'm sorry, I said that wrong. During drip, it wasn't starting the ramp with the EPR. It was starting the fan timing. That's what it was. It was starting the fan timing. I said that wrong. So you got your delay after defrost. So some of these stores, they're 20 minutes after defrost because it was starting the fan timer during drip. So if you had a 10-minute drip, so the fans were coming on before the refrigeration was even starting.
So if that's 10 minutes, then you'd have to probably put this like 15 minutes.
Yes. On the newer versions of Microthermal, like the last 5 updates, it's been fixed.
Yep.
So
old version. Yeah.
So you got time only. Click on that. You could do suction temp, air temp, coil temp. Now, when you choose this, it's going to make another input under inputs for you to assign something to.
Okay, so this is the threshold.
Yep.
This is for the fan fan restart. So 32 degrees is when it shuts off.
No. That's your value. So the threshold is when it kicks back on.
Why? Okay.
So it's reading 32 degrees because there's nothing assigned to it.
Oh, okay, that's fine. Okay.
Now, if you go to inputs now. Okay, now go to temperature. Top. Yep. Now see fan restart signal. At the bottom. Yep. Now you could assign just like you would assign a sensor to it. So you would drop it as a sensor on the screen. Okay. Now under the walk-in tab. To the left. Underneath the defrost walk-in. Okay, so you click the plus sign, add. Okay, now you could add your leak detection in. So if you had leak detection bypass switch, if you had a leak detection solenoid, if you had a leak detection suction stop, if you had fans and remote panels you were doing, you could do it here.
Okay, all right.
So not used a whole lot, but the leak detection is housed in here.
Defrost value, flow value. None of those would make sense. But all right, so never mind. I won't do that.
Yep. Now all your leak detection's in here. So now if you hit OK. All right. Hit OK. Okay, now I want to show you guys how to throw something in defrost. This is like the bare bones. Like this is what guys need to know.
Right here, right?
No. God damn it. Fuck. So, I'm going to kill you by the end of this. Hit the 3 hamburgers. Click on that. Go
actions.
Yes, go to actions. I hate you right now. Okay, that's where you would hit the start emergency defrost. There's no defrost assigned to this right now because Brett didn't program it.
You were the one fucking telling me how to do it, so don't say that Brett didn't do that. Kevin didn't tell me how to program it.
So go to defrost in the tab. So go to timing. Give it 3 defrosts a day.
Down to, this is down to.
Yeah, down to the bottom. 3 defrosts a day. There you go. Yep. Hit OK. So now the defrost is on here.
That's a lot of load.
This is what I love about microthermal. When you're tuning a defrost circuit or a defrost schedule, it's so much easier because you could just drag and drop. And then this red bar, if you set it up right and you have your BTUs in here, it'll show you when you're over a certain threshold. Okay. So it is fairly easy to stop doing Jesus. It is fairly easy to tune your defrost scheduling and move things around and match stuff up. Now, if you see where it says suction groups right underneath the process tab, you could overlay another rack on here. So if you had 2 coils in a big box, okay, you could overlay both coils on here and have it so you could see both coils so they're lined up. So if you got 2 ends of a box like a Costco or a Sam's Club where both coils need to go in defrost at the same time or they're going to frost over, you could match those 2 coils up so the times all match.
Gotcha.
Okay, now hit apply. No, wait.
I don't wonder if I don't have the Jeopardy thing, do I? Thought I did.
Hit OK. Okay, so we're going to go over how to force a defrost. This is and how to stop a defrost. So this is like number one what guys are going to need to do for service. So if you go click on the hamburger lines, go to actions.
It's just a hamburger. It's not hamburger lines. You still didn't program it right, apparently.
You don't have the board assigned to it, so it can't throw a defrost. So you have start emergency defrost and stop emergency defrost. Okay, and then extend defrost would also be in there. Now, some other stuff in here that click on it, close, go back to the hamburger lines. Okay, you have your config is how you get in there. You can duplicate this. So if you're making a bunch of coils, say I'm doing a bunch of like big coils and they're all the same, I will set it all up. I will leave the inputs and outputs out and I will just duplicate it over and over again. Okay, and then I'll go in and put my inputs and outputs in.
Move it now.
Yeah, you broke it.
Cancel.
So another great screen on here is if you go to you at the bottom, you got the EPR. Oh my God, what are you doing?
I'm going back in the notes. Oh no, it'd be in the suction control node.
For what?
The word to get all the hamburgers.
No, it's going to be in the circuit controller.
Right here.
Yeah.
Right here.
Okay. So at the bottom, you have EPR overrides. You have IO list. Yep. Okay. So IO list is going to give you all your IO points. EPR overrides are going to be how you override everything. IO list is going to show you all the inputs and outputs. So you could override or no override. And then you got relay overrides. So if you needed to test something, so you got relay overrides here. Now, this is a cool screen that not a lot of people know about. So if you go to current values at the bottom, all the way at the bottom, straight down, current values. Okay. This is going to give you current values of everything. Now, if you're assigned a node and it's updated, you have a lot more in here. So go to circuits. Okay. This is going to show you a ton of information in here. So if you go you get the highlights in here, it's going to show you whether it's yellow, it's on. If it's red, it's an alarm. It's going to show you the state of the relays down below. So it's going to give you all your states of your relays. It's going to give you pressures, temperatures. If you go to pressure regulation, top right there.
You could just say left, third one, second one down from highlights.
No.
I went to pressure regulation. This is where you told me to go.
Okay, so you have all your pressure regulation information in here, what it's going to have. So whether it's restricted for that reason, it's going to give you your limiting factors. It's going to give you all your information in here. Not a ton of stuff on here that's pertinent to what you want to know. It's just giving you base values and stuff like that. Now, if you go to valve and drive, this is where like this screen's awesome. Okay. Everything would be in here when it's assigned what it is. Okay. If it's a CDS9, whatever, it's going to show you the resistance on here. It's going to show you your ohms on that EPR. It's going to show you the amperages pulling. It's going to show you where it thinks it is in regards to where it is. That's how you change your circuits.
Wait, what the? Oh, for some
what did you just do?
No, it went there. Yeah. I don't know. Yeah. There
okay, so you got your valve drive. You got your ohms. So to the right, and the second right bottom side. You get your ohms, you get your current, you got your, this is how you reinitialize the valve if you need to zero it out. Everything's in here. There's a ton of information in here. Then you got your learning screen. It'll tell you if it's in learning. If it's not in learning, you can reset to learning. Superheat and dock mode would be where you're measuring the superheat coming back from the circuit, and it'll restrict the EEPR to try to keep it from flooding out. Great for after defrost, but this is like basically showing you where everything is on here. Did you break it?
No.
It's so blurry for me to see.
Where do you want me to go now?
I don't know. It's not moving.
I'm not doing anything.
Oh, okay.
So I was waiting for you to do stuff. I was gonna show him that there's a ton of info there.
God damn it, you're fucking retarded.
I know. Where am I going next?
Okay, if you were remaking more circuits, this is where you look. So let's just go over how to assign a board real quick, and then we'll wrap this up. This is a two-parter.
Let's stop here then. Then we'll assign it next time because we're almost talking for an hour.
Yeah.
So if that's cool, next week I'll be away, but no, I don't know. We'll figure it out. I'm home, but I'm training, so we'll figure the hell out. But I could always do splash top again. But yeah, if you're cool with that, then we'll do the board assigning next week and that. All right.
All right.
All right, guys. Till next time. We'll see you guys then.
Yep. Thanks for listening.
All right. Bye.